Hello class, welcome to Algebra Lesson 6.5, which is all about transformations of exponential functions. By the end of this lesson, you should be able to perform, analyze, and use transformations of exponential functions. So before I jump into the first example, I just want to connect this to past chapters that we've worked with. Back in Chapter 5 and also in Chapter 3, we looked at those types of transformations. Back in Chapter 5, we talked about how if there was a number in with the x, that it would shift the graph left and right, and if we had a number at the end, it would move the graph up and down. And we also talked about having numbers in front here as well, but I want to help you remember that whenever you have a number put with x, that's going to move it left and right. And whenever you have a number tacked onto the end, plus or minus, that's going to be something that moves your graph up or down. Okay, so example 1, looking at vertical translations of graphs of exponential functions. So how does the value of k affect the graph of f of x equals 2 to the x power plus k? So we have a lot of things going on this page. So let's break it down. First, let's look at our table. We have our x values. We plugged in -2, -1, 0, 1, and 2. We started with our parent function, f of x equals 2 to the x power. When we plugged those numbers in, this is what we got out. And that is this black line right here in the middle. Then we looked at g of x, and this is kind of hard to read, but here it has a +3. Okay, so that says +3. So what that does is, look, it moved everything up 3 units. So this green line represents g of x. So whenever you have something plus or minus on the end, remember that moves your graph up and down. And then the last column here, we have -3. So you can guess that, okay, -3 means I'm going to go down 3 units instead. So remember, whenever you have plus or minus a number after, that's when you are going to move the graph up and down. And when you move those graphs up and down, that also changes your range and it changes your asymptote, okay? So if we look at that plain f of x function, we would say, okay, my y-intercept was 1. For the green, it got added 3. For the red, we subtracted 3. My range for the green, the black one, the f of x, is y is greater than 0. For the green now, it would be y is greater than 3. And for the red, it would be y is greater than -3. So that means that my asymptote, I can't spell tonight, asymptote would be y equals 0 here. Over here would be y equals 3. And here would be y equals -3. Okay, so notice, pay attention to how adding or subtracting a number on the end impacts, the intercept range and asymptotes, okay? All right, question number 1. How does the graph of g of x equals 2 to the x power plus 1 compare to the graph of f of x equals 2 to the x power? Good luck. Hopefully you were able to identify that this would move up 1 unit. That's what that +1 does right there. All right, example 2. Let's look at horizontal translations of the graphs of exponential functions. So if we look at the graph, g of x equals 2 to the x minus h power. So again, here's our parent function right here. If we do minus 5, that's going to, remember, move it to the right because the general formula is a minus. So that means it does the opposite. If you plug a 5 in, it stays as x minus 5. If you plug a -5 in, you'd have x minus a 5, which becomes x plus 5. That's why a positive moves to the left and a negative moves to the right. Okay, so a plus, or moving right, a positive 5, means that you are going to move to the right. Or sorry, a positive 5 means that you'd have x minus 5, and that's how you move to the right. Okay, so when h is greater than 0, the graph goes to the right. However, if you have h is less than 0, so h is a negative number, that's when it moves to the left. Okay, this page just says that same thing. But notice for exponential functions, your h value goes up in the exponent. So up in the exponent, that's what's going to move your graph left and right this time. In chapter 5, it was inside absolute value or inside your step or your step functions. Now it's up in the exponent, moves it left and right. When you are looking at these and you're thinking about, okay, what changes when you shift the graph left and right? Some things to note: your y-intercept is going to change. It's going to hit the y-axis at a different spot, but otherwise your range stays the same with a horizontal translation. Your domain stays the same. You can still plug in any number you want. Okay, so not as many things are affected by a horizontal shift. All right, now it's your chance. Compare the graph of the function of the graph f of x equals 2 to the x power. What effect does h have on the graph of each? So g of x equals 2 raised to the x plus 2 power. Go ahead and state, how would this move? Good luck. All right, hopefully you identified that if it's plus 2, that's actually going to move us left 2 units. Okay, if you have questions about that, please be sure to ask for some help. All right, now let's compare two different transformations to the parent function, f of x equals 2 to the x power. So we have two different functions. We have the one in the table, and then we also have the one in the graph. So let's start with the one in the table, g of x. And let's figure out what's different between f of x and g of x. If we look, f of x had 0.25, g of x was 2.25, and then we had 0.5, 2.5, 1, 3, 2, 4, 2, 6. So you can see that each of these are 2 units higher, right? I added 2, I added 2, I added 2, I added 2, I added 2. 4 plus 2 is 6, 2 plus 2 is 4, 1 plus 2 is 3. Okay, so for g, the y values are 2 units greater. So that means a couple of things. One, the y-intercept of f is at 1. The y-intercept of g is at 3. And then the asymptotes of f of x would be y is equal to, 0. And then for g of x, it would be 2 units greater than that. So y would be equal to 2, right? Because everything just went up by 2. So those would be the things that changed. And then if we talked about range, the range of f of x is y is greater than 0. The range of g of x would be y is greater than 2. So my intercept changed, my asymptotes changed, the range changed. So I would list all of that information. Then let's go over here and look at our graphs. So you can see my parent function, the y-intercept for f is 1, for j is at 0. Look, it went down 1 unit. So that means that my asymptotes For f, that one's still at y equals 0. For j, it goes down 1 unit, so y equals -1. And then the range, f would be y is greater than 0, and j would be y is greater than -1. As you can see, it's just shifted down 1 unit. Okay, so that would be comparing to the parent functions. Then if we look and we compare our g and j, you could say that the y, so if we look, the y-intercept for g is at 3, the y-intercept for j is at 0. So I could say, all right, so g is a couple of units up. It is actually specifically 3 units up. So g is translated 3 units up. And then we could also say that the asymptote and the ranges are also adjusted. So the asymptotes and ranges are also adjusted by 3 units. Okay, so that's how you kind of go through and you compare. You look at the different intercepts, the different asymptotes, the different ranges, and you see, okay, how are they different, and just kind of highlight those differences. Okay, so if you have any questions about that, please reach out for help. Otherwise, this is your concept summary for this section. Hopefully this helps you keep everything straight. But like I said, if you're still having questions, please be sure to ask for some help. I am happy to help you. Have a great day.